This video is going to cover the calibration of the pressure and force transducers of the 114 system. Regular calibrations are important in maintaining the accuracy of the data generated using these systems. Neither procedure takes much time, and both are vital in keeping the system in top working order. We're going to start with the pressure calibration. This is important in making sure that your vessels are seeing the actual pressures you are setting in the software as the target pressures. In order to do the pressure calibration, you will need a big bend pressure manometer and a calibration shunt. In order to set up the system for the pressure calibration, you want to make sure that the interface is powered on and connected to the chamber, that you have air in all the lines, and the P2 bottle cap is securely in place. To set up the chamber for the calibration, you need to place your calibration shunt on the chamber bypassing the cannulas. So we will disconnect the left side cannula mount tubing and attach the calibration shunt, and then using your non-dissection forceps, place the calibration shunt on the right side, bypassing that cannula. We then need to connect our pressure manometer to the right side three-way valve and make sure that your three-way valves are pointing in the correct direction to ensure that you don't have any pressure leak. On the right side, we have our open port closed. On the left side, we have the bottom port, which is open, also closed. We can then begin the pressure calibration. We will go into the settings menu on the interface and go to pressure calibration. This says that it's a 5-step process and you should follow the procedure in the user manual. However, instructions are also provided on the touchscreen. Select next step, which will then ask us to apply 50 millimeters of mercury pressure using the manometer. So we will add that pressure. And pressure should be holding. It is here, which is good. If you are losing pressure, that means you have a leak somewhere. It could mean that you have the three-way valve in the wrong direction, your bottle cap not tightened, or a leak in the tubing. But the pressure is holding at 50, and you can see the P1, P2, and P3 pressure readings have all increased. At each step, you want to make sure that the readings are increasing similarly. So these are all in the 36 to 3700, which is good. We can hit next step, and it will ask us to go to 125 millimeters of mercury. So we add that pressure. Again, pressure is holding. You can see our readings have all increased in the 42 to 4300 range, again, which is good. Hit next step. The final step is 200 millimeters of mercury. Be cautious not to go too high, as the transducers can blow once you bypass 250 millimeters of mercury. So we increase to 200. Pressure is holding again. You can see our pressure readings have all increased again. We can hit next step. The final step is ensuring that each reading is approximately 200 millimeters of mercury. You can see all are around that number. So we finalize with the next step, and pressure is now released internally. But that concludes the pressure calibration. We will now cover the force calibration procedure. This is important to perform in order to have accurate force readings, as you are using the force transducer to apply standardized stretch between each vessel of your experimental group. To do this procedure, you will need the calibration force kit that came with your 114 system, and make sure that you have your myograph cable connected to your interface. We will go into the settings menu and go into the force calibration. For those familiar with the 620, the wire myograph force calibration, this is the same procedure. The first step tells you to follow the procedure in the user manual. However, instructions will be provided on the screen here. Hit next step, which tells you to place the calibration bridge and T-balance on the chamber. You will see the calibration bridge has a unique design which should allow it to only fit one way on your chamber. This cutout on the side will go over the force transducer itself. Now you drop the T-balance in on the left side mount behind the screw. You want it to be as close as possible behind this mount without touching. Go to next step, which will tell you to make sure that heat is on. The force calibration is best performed under experimental conditions with the heat on and water or buffer in your chamber at the same volume you will use during your experiments. You can also do this at room temperature, but you do not want to do the procedure while the system is warming in the first 20 minutes after turning on heat. We will go to the next step. Step 4 asks you to make sure that the force transducer is not subjected to any force. You want this number to be steady or going back and forth between two numbers. If that number is drifting in one direction or the other, it means that the force transducer is being subjected to a force. Recheck the position of your calibration bridge and then click next step. You are now asked to place a 2-gram weight on the calibration bridge. You will place it on the left side of the bridge, which will add force to the transducer. Give this 20 to 30 seconds to stabilize, and then go to the next step. This number should be approximately 9.81, and as long as it's within 0.1, you can conclude the calibration by clicking next step. That concludes the force calibration. You can then remove the weight and the calibration bridge. For more information, please refer to the 114 user manual found on the DMT website or additional resource videos.